Just readdressing cations and anions and kind of where they're at on the periodic table. Because you kind of know what they'll do based upon their position on the periodic table and their electron configuration. So what I'm going to do is, I'll put some terms up here a little bit later, but what we're going to do is we're going to show, for example, a real simple example. We'll do sodium, and sodium is Na, and I'm going to go ahead. You guys do not have to write down the shorthand configuration. So I'm going to go ahead and show configuration, kind of see how that works in. And hopefully it ties everything in together, what we've done. So I'm going to go ahead and show sodium. And sodium is 1s2, 2s2. Again, you don't have to show this. 2p6, 3s1.
This is the last one that literally looked like his pulse. And then I hacked him with it and I rolled it. But I settled for it. I'm not even kidding. I'm literally like a dog and I tomorrow. Yeah, we have to go around. I'm also wearing the shirt. Okay, I get my Christmas socks. You said tomorrow. I thought you meant you just. Yeah. That's my dad.
Okay, so you should see a lot of kind of light bulbs going off. I hope I do, or at least some things getting connected here. We've done a lot of processes, so you guys have processed a lot of information, and hopefully you understand electron configuration, which most of you did really well on that. You, when you guys did your trends, you did some drawings and actually did these drawings here, and those drawings kind of help you kind of figure out some things on, you know, why certain electrons are held tighter and pulled in versus other ones. And so here's the electron configuration for fluorine, and here's for sodium. One's called a metal. This is a metal, and fluorine's a non-metal. And metals and non-metals tend to get together to form what we call ionic compounds. Ionic compound, what is it? Well, it's something where ions are formed by losing and gaining electrons. And when they lose and gain electrons, they become charged. And we know opposite charges will attract one another. So the result of gaining and losing electrons are charges that are opposite of one another that they'll tend to pull together to form a bond. And we call that an ionic bond, when opposite charges of opposite ions attract one another. So everybody can see that the best way for this to get an octet of electrons, sodium, is to lose the one electron, right? You guys see that? You can see it in two ways. You can see it up here. You can see that this electron, when it's lost, it's got to go somewhere. It's just not lost, and it has to have a place to go. It's just not lost to be lost. It has to have something that will accept it. So when we lose that electron, we lose this whole outer shell here. And now we have 11 protons and 10 electrons. So we have 11 protons and 10 electrons, and so that's going to be a +1 value. So this is a +1 right here. Okay? And now it has 8 electrons around it, right? It has an octet. Now, fluorine is the one that really wants it. It has the highest electron affinity of any element. You can kind of see why. Here's the nucleus. The nucleus is made up of 9 protons, and it's going to want that one electron that was lost over here to be brought over here, and when it does, it brings it in, and it gets that electron from sodium that was right here, pulls it in, and now this becomes not 5, but it becomes 6. Look at them, they have the same electron configuration now. Okay, they're in the same, their sodium's in the row below it. And so now they're stable. But now that they're stable, this one has a -1 charge and that has a +1 charge. So these two, since they're opposite charges, are going to come together, right? And they're going to come together to form an ionic bond. So does some of that kind of come together now? Electron configuration, kind of see how that works? And so everything wants to get a S2P6 configuration. Everything wants to get an S2P6 configuration. Because that's where it's stable. For some reason, that octet rule of getting 8 electrons in the outer level at any point in time. So we don't want to show this every single time. I want to show another one of these. You can write it down. You don't have to. Just to show you how it's not as simple as this every single time. Okay. So maybe we'll do a different one. Okay. And we're just going to do the shorthand version of it. So I'm going to go calcium. And calcium is right by, so it's a 4s2, right? 4s2. And then the element above is argon. Okay. So it's argon 4s2. It's got those 2 electrons. Okay. We're going to pair it up. Now I'm going to do one that's pretty tough to do, but I think I'm going to do it because I think you can see how it's going to progress. And so I'm going to do nitrogen, and so nitrogen is neon, and I think it's 2s2, 2p3, right? You guys agree with that?
Nope, I'm just going to...
How would nitrogen be? I think it's helium, not nitrogen.
Okay, thank you. You're right. Helium. Right. So, now, I'm just going to do the outer level and for calcium, so I'm just going to show the outer level. Yeah, I better not do that because then it's the 4th level, right? Yeah. So I'm going to show that those 2 electrons in the outer level. That's a 2s2 for calcium, and then I'm going to show nitrogen. And it only has 2 levels. It's 1, 2, 3. You guys see that? So this is calcium, and this is nitrogen. All right. All right. So here's the deal. Calcium will give up its 2 electrons. Let's go ahead and do that. I'm going to go ahead and duplicate this page. So calcium's going to get rid of its 2 electrons. What charge does it become? Positive what?
2.
2. So now it's a positive 2. Those 2 electrons, they'll come down here. 1, 2. Does nitrogen have an octet?
No.
No. So what has to happen is it's got to get more electrons. So we have to bring in another calcium. So we bring in another calcium.
Where are we getting this calcium at?
These calciums there's trillions and trillions of them floating around.
Oh, okay.
So they're plentiful. It's not like there's one calcium and that you're done. Okay. There's trillions and trillions and trillions of calcium in a sample. So here comes another one of those trillion. And it has a 4s2. Okay. So this one, this calcium that has these 2 electrons here, it's going to get rid of one of those 2. Okay? So it's going to get rid of one of the 2. Now this is a progression. This all happens in a blink of an eye. Alright, so that electron goes here. Now we have nitrogen fulfilled. It's got its 6, right? Any questions? It's got the ones that are brought in. It's got them here, and here, and here. But what's the problem?
You have one more calcium.
I got another electron that calcium is not going to hold on to.
That's the one you drink.
So, where does that one go? What's that? Doesn't stay with calcium. Where's it going to go? Remember I said calcium, there's trillions and trillions of them.
You gotta make
It goes.
I got to make another nitrogen. Oh my God. Now, you will never have to do this in this way. Okay? I'm just showing you that when this happens, the number of electrons gained and lost have to be to the point where everything equals out to 8. Until it equals out to 8, it's not going to work. Until we equal out to 8. So you see it has that 1 out there, and it wants to get rid of that 1. So it's going to get rid of that 1, okay, which it gets rid of this, and we get another calcium plus 2. Go ahead and make sure my colors are right. Okay. So calcium plus 2. Alright, and so where's that other electron go? It goes to another nitrogen. And you got 2s2, 2p3 to begin with. Because these all have the same configurations. So then that electron, that fourth electron, goes here. Then you got to make it. So this becomes a -3. And then this one here is a -1. You got to bring in another calcium. So I'm not going to do it. But I'm going to go ahead and bring in another calcium, get rid of it. So then I've got another calcium plus 2. If you notice something about the charges, when you're done, so that other one brings in 2 electrons. And so when you look at your charges when you're done, what do you notice about the pluses and minuses? They equal one another. Okay? They equal one another. So, what's the ratio of that then? So if these two get together, the first one, our ratio was 1 to 1. Okay? So the very first one we did, we said, hey, these two get together perfectly. A +1 matches up with the -1. And you get a ratio that would be NAF. That's how they go together. +1 and -1 cancel each other out. You just have to have one of each. Okay? So, on this one, we have to have 3 of these for every 2 of these. And so that would be Ca what? How many calciums? 3.
Yeah.
There's 3 calciums, right?
Yeah. Oh, yeah. Yes.
1, 2, 3. How many?
2.
Nitrogens. 2. So, that's the ratio that they'll get. So you're like, Mr. Garland, there's got to be a simpler way to do this. This is way too confusing. I could never do this. All right? And I agree with you. It's something that I'm showing you why the arrows are going where they are, why they fulfill the octet rule at the end, and every one of these fulfill the octet rule. So I'm going to show you a couple things here before we get done. This is taking longer than I thought, but that's okay. It's a Monday after break. So I'm going to show you what this thing called electron dot notation. Now we did orbital notation with the lines. Electron dot notation is so much easier. So much easier.
Do you
Is it like connect dots or something?
Electron dot notation.
I don't know what I'm
Okay? So, when you look at your periodic table, we only look at the outer level when we do electron dot notation, just kind of like shorthand. We only look at the outer level for the most part. And so, I'm going to do a couple elements, and you're going to do a couple elements. It's going to be that quick. You'll have this figured out in 2 to 3 minutes. Be that quick. First one I'm going to do is I'm going to do oxygen. So you go to the row that oxygen's in, and you count across. And you count how many symbols, including the symbol you're going to, how many symbols do you have going across? So how many? You have 6, right? Including oxygen. 1, 2, 3, 4, 5, 6. So this is what you do. You go, here's the first 2. You guys know what those are, right? What sublevels are those? S. So 1, 2, 3, 4, 5, 6. There it is.
I can do that.
Is that it?
That's it.
I'm gonna do this.
You count across.
We should do another one.
1, 2, 3, 4, 5, 6. Oxygen across the row. Okay. So,
I get it.
okay. So you guys know what these bottom 3 represent, right?
P.
P. And so don't write this down. Okay. So this is the shorthand. This is a shorthand for. This is a really shorthand for doing this because that symbolizes these arrows. You see that?
How would you do one with D?
Oh, wait a second. Okay, does that make sense? These arrows are these dots. What they are. Right, so we don't have to show these anymore down here. Okay, let's do another one. Do real easy. I want you to do barium. Do barium on your own. Ba. Guys done?
Where's
I haven't found it yet.
Oh, there it is.
Ba. Alright, you guys done? Okay, here's barium.
Yeah!
Yeah.
Wait, so you don't have to draw a circle?
No, this oxygen represents.
Oh, that's
Oh, oxygen.
Oh.
Oh.
I thought that was an
I thought that was like a layer or something. Like,
I didn't make my own very good. It looks like a regular orbital, doesn't it? Okay, go ahead, and I'm going to have you do 2 more. I want you to do aluminum, and I want you to do arsenic. Aluminum and arsenic. And then we'll be done with that part.
Oh, see, this.
I get it now. I feel it. I don't know where to go.
Al and As. So Al has 3, right?
Yeah, I got it.
And As has 5.
Wait, you don't count the D's? You don't count the D's at all?
Did I?
No, because they are always inner level, right?
I took my best guess.
The D's are always inner level. We only count the outer level or valence electrons. And you can only have 8, so once you get past 8 and you get to 9, 10 around it, you're like, wait a second, Mr. Garland said there's only supposed to be 8. I'm counting the D's, I can't count the D's. Or the F's.
So then how do you do it if something is in, like, say,
Yeah, so Cole asked a question, how do you do, listen, how do you do an element that's in the middle there? They're always going to have 2. No, they're only going to have 2 dots. Only 2 dots. Because of the S. So, and we don't focus on the middle because that comes later when we they kind of have multiple charges where they'll lose different amounts. So we focus only on the S's and P's for now. Okay? So I want you guys to look up here. I'm going to draw some, since you guys don't know how to do electron dot notation already, I'm going to draw some ones up here. I want you to predict how many is going to be gained or lost by my drawing. Okay? I think you guys can do this. All right? Really do.
Bobby knows which ones we're gonna lose.
So, you know that side too? Sit. Yummy.
Okay. So this is the last thing we're gonna talk about, and we'll combine a couple concepts here real quick. So you guys tell me, selenium, will it tend to gain or lose?
Gain.
How many?
2.
Okay. If it gains 2, what's its charge? Minus 2. I know you can. Chlorine, gain or lose?
Gain.
How many?
1.
Charge.
-1.
Barium.
Plus
Loses. What charge? Whatever it loses is what its charge is going to be. Aluminum. Gain or lose?
Lose.
Lose.
+3. Lose. Oh.
5.
Gain.
Gain.
Oh, phosphorus.
And then last 2, this would, potassium would lose.
Plus 1.
And then these would lose, right? And what charge is germanium?
+3.
Plus 3. Okay. All right. So we're going to do a little game here real quick. And this will help you on your assignment.
I love games.
You love games? Okay? So let's just choose 2 that will tend to get together, and let's start out really easy. So if you had one that we want to do, it's really easy of how they kind of go together in ratio. Pick 2 that you think go together really well. What's that? Okay, so we got selenium and barium. If they go together, what's its ratio going to be? 1 to 1. It's going to be Ba what? Se. Okay, let's pick another one.
Chlorine and potassium.
Which one? Chlorine and potassium? Alright, let's not make it so easy. Let's do one that's a little more difficult.
Chlorine and germanium.
Chlorine and germanium.
God, why you gotta... You said not make it easy.
How many do you need of each? What's the ratio?
1 to 3.
Which one's going to be 1?
Chlorine. Germanium's gonna be 1?
Yep.
Yeah, you need 1 of those. And 3.
Chlorine's got to match the charge of germanium.
Oh.
3.
It's got to match it. So I got to have 3 of these to match that plus 3. Okay? To match it. So it'd be GeCl3. Does that make sense?
Yeah. A little bit.
Okay? Let's do...
Basically just switching the numbers, right?
You can think of it that way.
That's nice.
Okay? If you think of it that way and know the reasons why, you can do that. Let's do the last one, selenium and aluminum. These 2 right here.
They both go to 6. So it's 3 seleniums for every 2 aluminums.
Yeah, you got to match the charges. So the only way they match is if you get them to 6. It's kind of like a common denominator when you add fractions, right? If you got a 1/2 and 1/3, what do you have to get both of them to add them? You got to get them to what? Denominator to 6. If you got a 2 and a 3, you always have to get it to a charge of 6. So it'd be Se what?
3.
3.
Al1.
2.
Al2. You want to put the metal in front. You want the positives in front. Questions? Okay, I've got an easy, it'll seem like it's a long assignment. You guys have had a week off. You guys need some work time.
Oh, we don't need that. Oh, yeah, we need yeah.
And it'll seem long, but it'll go really quick because each problem is super simple. Okay, super simple. So, your assignment is on page 171. And you're going to do the evens. 2, 4, 6, 10, 16, 18, and 20. Each of them have A, B, C, D.
So 2 through 20.
So 2, 4, 6, 10, 16, 18, 20. So when you start looking at them and going, man, Mr. Garland, this is really easy. You should have gave us more.
No.
Give us a...
I don't recall.
Be like electrons or be like nonmetals. Want more. More. Give me more.
Don't recall.
Never.
Okay.
Where's that song?
So they call ionic.